Hi, welcome back to CS 170. So I'm going to pick up a couple of lectures to deal with chapter 22. So in general, chapter 22 talks about uh, basically what you might call the cutting edge or the leading edge for where the computers are right now. Frontiers, I guess you should call it, right? So we'll cover these couple of different topics in a similar vein as like the history type of questions or whatever for CS 170 from the beginning. There's going to be a lot of this type of information within the book that you should definitely read over and go through it. So I'll try to hit some highlights, try to hit some examples, um, but do make sure you go into the book. The book probably has like a little bit more details and a wider breadth than what I'm going to cover. I'm not going to really regurgitate what the book is saying word for word. So we're picking select topics out of the book and with some examples off of that. So do pay attention to that. And before I start on this, there were some questions that came up for the recitation project. So one of them was around the 25 points for the exercise 11. So that should be fixed now. So that is 25 points. So 9 and 10 were 20, 11 was 25. Then there was also some question about the points for the quizzes, which also should be getting addressed. I think specifically it was around quiz number 7, whether it was 5 or 10 points. So it should be 10 points, and I've put in a request to get that fixed, so that should line up to what the recitation project's talking about. Okay, so here you can see the learning objectives here. So the Turing test, I'll speak about that in a second, but it's a pretty famous test posed for computer science. So I'll mention that a little bit. And then we talk about the idea of computer intelligence, taking that from, for the uninitiated, it's a pretty famous computer used to play chess. And how it's evolved to probably what you may have seen in the news maybe recently, maybe in the last couple of years or so with AlphaGo. Okay, and then the universality principle, which is something that the book kind of mentions, and there's like different types of problems which are considered very challenging for current types of computer processing. And I'll get into that a little bit. Okay, so the first topic I'm going to cover with this video is talking about the idea whether computers can think or not. So the idea, and this is proposed, and I don't know if some of you may have noticed there's movies out there, but it's very easy. You can kind of look at all kinds of material on the internet about Alan Turing. Okay, and so he's basically one of the early people. He was kind of famous for doing code breaking during World War II using computers, and so he came up with this idea of to test whether a computer can basically fool you to think that they're a human. Okay, so it's called the Turing Test. Um, so you have this person here, B, and then you have this person as an A, and you have this person over here who's a C, and you don't see anything, right? You can't tell which one's a human, which one's a machine. Okay, and basically you have a conversation, you have interaction, and if a machine is good enough to fool this person C, that's considered passing the Turing test, right? So at the time when he came out with it, it was very easy for you to figure out that you're talking to a computer behind this wall here, okay? But I think over time, it's gotten more and more sophisticated for any number of reasons, which I'm not going to go into here. But that's basically the intelligence test for a computer, okay? Um, yeah, so the idea here is that instead of trying to list all the attributes to kind of say, oh, this is a computer that is thinking, um, it's basically running a test, uh, like a blind taste test or something like that, uh, for you to figure out whether it's a human. So it kind of simplifies things a bit instead of trying to list all these attributes, which you know obviously people will come up with all these different exceptions and whatnot to say, like, oh, computer can do this. Oh, well, that's not really thinking. And stuff like that. And we'll kind of go into that a little bit when you look at things like the initial chess playing games to some of the things that the computers are doing now. Um, so, so this part here, that's an important concept here for this Turing test here, right? So it gets out of the way of doing a definition of thinking, right, and focuses on a test, right? Um, and this just kind of talks about where the computers are right now, um, and where its progress is. Okay, so on the Turing test, there was probably some things in the news. um, you may or may not have noticed it, and they talked about this idea where this AI passed the Turing test, right? And you can see from here, I have a screenshot of it. This is back in 2014. Okay. Uh, and it's like simulates a 13-year-old boy uh, having passed the Turing test. Okay. um, I think later on, that kind of passed off. I think there was like some debate about whether they actually passed the Turing test or not. um, so you know I think ultimately no, right? And then they moved on to here, where they talked about something from Google and whether it passed the Turing test. Um, so uh, I think it was closer to passing the Turing test. Again, it's another open debate as to whether it really passed the Turing test or not. Okay. Um, And so this is talking about different things that the computer does. Um, and to say, well, it's good, it does certain things. In this case, it's talking about the spelling and grammar checks. Um, but it doesn't have to understand the context, right? So just being able to do spelling and grammar checks doesn't indicate intelligence, okay? Um, Now they talk about this early interactive um, type of program called ELIZA. It was developed by MIT many years ago. I don't remember exactly what year it was, but it was a long time ago. And it was programmed to keep a dialogue going. Um, it wasn't that hard to, uh, you know, ask certain types of questions to kind of get it to basically reveal itself that it wasn't intelligence. Okay. And it was just like basically this command line type of interface with Eliza, right? So here's Eliza talking, uh, and you can kind of, have some sentences here, right? This person's name is Amit, uh, and kind of having the simple types of information. Okay. Um, Before I go into the chess, but I'm going to cut the video at this part where it says the artificial intelligence. Okay. Um, so, although you have the Turing test that we've just been talking about here, um, this tries to talk about a couple of points here. So one is talking about intelligence for the computer, kind of stepping a little bit into the definition we were just saying that we were trying to avoid by using the Turing test. Um, so, so the computer understands a situation and acts based on that situation. So it's not like, oh, here's a specific algorithm, and if it's green, go. If it's red, stop, or something like that. Um, it's a little bit more of a deeper understanding and saying, is it proper to go or not? So the actions can't be scripted, pre-programmed, predetermined, right? So systems would have to understand natural language and or have real-world knowledge. Okay, um, so you can think about something like this, where you have, uh, let's say, you know, a car that drives. Um, it's almost infinite, like the number of things you would have to program. So let's say computer is not able to think at all. You have to tell it exactly every single thing to do, right? Um, so yeah, maybe if there's nothing, it's just a straight road, and you just say, okay, look at the lane markers and keep your car driving at a certain distance and adjust the steering left or right if the road turns or not. Okay, that's fine. That's straightforward, right? But when you introduce all these other real world variables, and not all of those variables are predictable, i.e. like a person, wandering on the side of the road, or a crowd of people, animals that pop up randomly, weather conditions, intersections, traffic lights, stop sign, yield signs, all of these different types of variables that pop in there. It's practically impossible to try and program that. Um, so, uh, this is where the idea of AI is supposed to come forth, where you're supposed to evaluate those situations. Maybe you kind of group certain classes of objects and their behavior, and then trying to come up with an evaluation of what you should do. Right? Maybe you have to slam on the brakes. Maybe you have to slow down. Maybe you have to like swerve to the left or swerve to the right, or whatever it is. Those type of things are not things that you're just going to write some code uh, and do that, right? It will be like almost infinite number of cases you have to support. So this is kind of what this is trying to say here with the AI, right? Understanding the situation. You don't script it or pre-program it, right? And we'll kind of go into that a little bit when we go into like the early stages with playing chess and stuff like that. But I'm going to cut a new video for that, okay? And remember what I said at the beginning of this lecture. There's a couple of things related to um, the uh, the recitation project. So note the point I just said about um, the assignment 11 being 25 points, and the quiz number 7 being 10 points. Okay, so that should match up to what your recitation says. I know people got confused when they look at the grading, which was off, and we're getting that fixed right now. Okay. If there's any other questions about the recitation project, remember we have the lab hours. Lab hours are open to everybody. Doesn't matter what section you're in. So just hop into those and get those done. Thursday night is when you should get your recitation project in. Next week we should be opening up the quizzes, the old exams, everything like that. So you should be able to review for your finals. Okay. If there's any questions, give me a shout. Thank you.